Hello everyone, welcome back to the session. So in today's class we are going to discuss about an amino acid. So in the yesterday's class we have discussed about the lipid and we have completed. In today's class we are going to start the amino acids, and this tomorrow's class also we are going to give some leftover topics of today regarding this amino acids by in addition to the protein. So in today and tomorrow we are going to discuss about this amino acids and proteins, right? So this is what an amino acid structure. So before entering into any of the biomolecules, you should know what will be the basic monomer of that particular polymer, that is nothing but a biomolecule. So say for an example, in carbohydrates the basic simpler form of carbohydrates will be the monosaccharides, that is the glucose. And in the lipids, in yesterday's class we have discussed about the basic unit of this lipid is fatty acid plus glycerol. So like in the same way, the protein, the simpler form of the protein, the simpler structure of the protein, which means whenever the protein is getting digested, it has been split up into different amino acids. So we can say that a group of amino acids together we are calling them as a polypeptide, which is nothing but a protein. And this is the basic structure of an amino acid. See, we have a central metal atom of carbon. There is a central carbon atom, and in the left side we can see we can have the amino group, and in the right side we can have the COH group, that is nothing but a carboxylic group. And in the upper side we are having a hydrogen molecule, and the lower side we are having an alkyl group. And this R is called as a side chain, and this R has been replaced by some other alkyl group, and we can name that into different amino acids. So for all the amino acids, so we are having approximately 300 amino acids, but the most commonly existing amino acids will be 20 amino acids, and we are having different types of amino acids. We are going to discuss about that, but you should know that the basic structure of amino acids will be the central carbon atom, and it is having an amino group, and it is having a carboxylic group, and they are having a hydrogen atom, and they are having the side chain, R chain. So this will be the basic structure of an amino acid. For example, we are having 20 amino acids, and the best example will be the glycine. So in the glycine, if the R is replaced with the H, then we are calling this particular amino acid glycine. And if the R has been replaced by the CH3 group, then we are calling this particular amino acid as an alanine. So this will be the basic structure of an amino acid. Excuse me. Sorry. So the side chain has been replaced with other alkyl group, and by seeing the side chain we are naming each and every amino acid, and we are having different types of amino acid. We are going to discuss about all those things. See, the very important thing will be, so we are having a central carbon atom, that H has been given here, that is what CH, and here there is an NH2. Always there will be an NH2 group will be there, and see, just look at this picture. This is NH2, and just look at this picture, and look this structure. Here we can have this NH3. How it has been existing like this, let me explain you. So if amino acid structure will be like this, like NH3 plus and COO minus, here it is originally it will be COOH, and this H has been donated by this carboxylic acid to this, and here it will be the donor of the hydrogen, and here it will be the acceptor of the hydrogen. As it has been accepted, here a positive charge. As it is donated, it has a negative charge. So as we are having plus and minus, there will be no net charge. The plus and minus has been cancelled each other. So as it is having a neutral charge, which means as there are having a no charge in an amino acid, we are calling that particular ion as an Zwitterion. Right? So alpha amino acid in the sense, this is an alpha carbon. We are naming this carbon as an alpha carbon. As an amino group has been attached to this alpha carbon, we are calling this particular amino acid as alpha amino acid. Let me explain you once again. So here originally there will be COOH, and here originally it will be CNH2, and here this hydrogen has been donated to this donated, and that donated hydrogen has been accepted by this NH3. As a result of acceptance of one hydrogen, it becomes NH3, and it is in an positive state. And just look at the COO. As it is donating the hydrogen, it acquires a negative charge. As they are having +1 and -1, as a result 0, there will be no charge. So that is why we are saying at this is the state of an amino acid. We are calling this ion as a Zwitterion. This is very important. Now just coming here. So it will be an original state of the amino acid. We are having a central carbon atom, and we are having an hydrogen, we are having a side chain group, and we are having a complete COOH group, that is carboxylic group, and we are having an H2 group, that is an amino group. So this will be the basic structure of an amino acid. So this is what we can say this particular amino acid, alpha amino acid, again it is an unchanged molecule, not an accurate representation of an amino acid structure. So you should know this amino acid can't exist in nature. Why? Because the amino acid has to be react with something, only then it can become a polypeptide, and it can make up the protein. Definitely it has to react with something. So that is why we are saying that this particular amino acid is not an accurate representation of an amino acid structure. But you should know it always exhibit, either it will be donating a proton or it will be accepting a proton. This is how an amino acid will be. So this is what a basic difference you should know. Now, how a peptide bond has to be formed. So before we enter into a bond formation, you should know a group of amino acid together make up a protein, and how one amino acid is getting attached with another amino acid by a bond which is called as a peptide bond, and how the peptide bond is going to form. So this is what a picture. Just look at this picture. Here we are having an H2, no doubt about that, and we are having a hydrogen group, and we are having an R group, that is a side chain group, and also we are having a carboxylic group, and one amino acid and another amino acid. Together they are joining. How they are joining? Just look at this picture very carefully. So we are having the COO, isn't it? And the hydrogen of one, the amino group having a hydrogen, and one hydrogen from the one amino acid and OH from amino acid, that has been released as what? Water. And the water has been removed. Now as a result, C double bond O and NH has been formed. So this bond is called as a peptide bond, and this peptide bond has been formed as a result of condensation reaction. And why we are calling this particular reaction as a condensation reaction? See, water has been released. So that is why we are saying that as a condensation reaction. Very important. See, let me explain you once again. A group of amino acid, we are calling that particular thing, biomolecule, as a protein. And protein, so to make up all the protein amino acids together, one amino acid has to be connect with another amino acid. For that, how one amino acid is going to connect with another? So we know the basic structure of an amino acid, and this will be an amino acid 1 and this will be an amino acid 2. And here the carboxylic group, the OH group, belongs to the carboxylic group of one amino acid, and the hydrogen belongs to the amine group. The hydrogen belongs to the amino group of the second amino acid, that specifically in the amino group, isn't it? So they both has been eliminated as a water, and they have been formed COO, which C double bond O and N single bond H. So this is what the peptide bond formation, and the peptide bond has been formed in the means of condensation reaction. So this is very important in an exam point of view. Now, so see here, so just look at this picture, the same thing have been repeating again. See, this is what an one amino acid and this is another amino acid. Here the OH group has been removed and here the H group has been removed. H group from the amino group has been removed. Now as a result of this, hydrogen molecule has been eliminated. Now this is what a bond formation. So this is the bond formation. What is the name of the bond? Peptide bond formation. This is very important. Now we are coming to the theoretical part. So how can we define this amino acid? So this amino acid, we are calling that particular amino acid as an organic compounds. Organic compounds which contains an hydrogen atom, an amino group, and carboxylic group, and the variable side chain. Why we are saying as a variable side chain instead of the word constant side chain? Just now I have explained you, all the three functional group has been same for all the amino acid, but only the R group has been changed for all the amino acids. So that is why we are saying the side chain is variable instead of constant. Now R has been attached to a central alpha carbon, so that is why we keep on saying that as an alpha amino acid, as it has been attached to a central alpha carbon atom. Right? As there is only one carbon present in it, we are naming that particular carbon as alpha. Now, so this is very important point. This can be frequently expected in an exam. So these are all the building blocks of protein, no doubt about that. Now, what will be the general molecular formula for an amino acid? There is a central carbon atom attached with the hydrogen and an amino group, and here it will be a carboxylic group, and here it will be a side chain, variable side chain. That's what represented here. And just to look at this picture, we are having an alpha carbon, and carbon have four valencies, so that is why it has been satisfied here. 1, 2, 3, 4, and carbon has four valencies and it has been balanced. So the central carbon atom has been attached to four different groups, not similar groups. And in the glycine amino acid, they are having three different groups. Why? Because there is an amino group, central carbon atom, carboxylic group, and here also an hydrogen atom, here also an hydrogen atom. So that is why for glycine it has been attached to three different groups. But again, in glycine also we can say that as an side chain, because that R has been replaced by the H. So anyhow, as two hydrogen has been present in the glycine, it has been attached to three different groups. Just note this down. Yeah. Makes amino acid chiral except this glycine. See, in yesterday's, I think in the previous day before yesterday, we have discussed about a carbohydrate. Whenever we are discussing about a carbohydrate, we have discussed about the chiral carbon. Chiral carbon in the sense as carbon has been attached with four different groups. See, carbon has a four valencies and it has to be attached with something. And here a different amino group, here also a different carboxylic group, here also a hydrogen different group, and here it is an R group. So four different groups, that makes an amino acid chiral. That makes an amino acid chiral. But as I have explained you before, we are having a glycine. So one side amino group, one side carboxylic group, central carbon, and here also hydrogen, and here also hydrogen. This doesn't make a carbon chiral. So that is why all other amino acids are chiral amino acid, but except glycine, as it has been two hydrogen on their both sides. So chirality, what is meant by chirality? As I have been explained you before, this alpha amino acids are optically active. So except there will be no chirality in case of glycine, as it has no, all the four sides are not equal. So except glycine. So the question can be asked like this: the optically inactive amino acid is which amino acid? Which amino acid is optically inactive? So all the amino acids are optically active except glycine, which is optically inactive. So in an exam, when you come across with a statement all amino acids are optically active amino acid, that statement is false statement. But you should know that. Why you should know that? Because this glycine is optically inactive amino acid, as it not obeys the chirality. And it occurs mainly in L form in biological systems. It is mainly in the L form in the biological systems. So in the previous classes itself, whenever we are dealing with the carbohydrates, we come across with D and L. Yes. Now, classification of an amino acids based on the nutritional requirement. So we are having different types of amino acids. So based on the nutritional requirement, we can categorize an amino acids into two. So totally we are having 20 amino acids. So this is very, very important point. So frequently we can expect question from here. Just look at this. Based on the nutritional requirement, we are having two different types of amino acids. One is essential amino acids and another one is non-essential amino acids. So what is meant by this essential amino acids and non-essential amino acids? Essential amino acids in the sense they cannot synthesized in the body. Non-essential amino acids, they can be as it is synthesized in our body, we don't need to seek an that type of protein from the diet. So in case of essential amino acids, they cannot be synthesized in the body, that has been taken in the form of diet. Through diet. So this is very important. Valine, leucine, isoleucine, methionine, phenylalanine, tryptophan, threonine, lysine and histidine. So essential in children, histidine. So this will be the mnemonic. Just go through it and memorize it. Definitely this is very important area where we can expect a question. So based, as I let me explain you once again. So based on the nutritional requirement, we are having two different types of amino acids. One is essential and another one is non-essential. As it is essential amino acid, our body needs this amino acid in the means of diet. Non-essential amino acid in the sense as our body synthesizing of its own, it doesn't need to seek it from the diet. So what are all the essential amino acids? Valine, leucine, isoleucine, methionine, phenylalanine, tryptophan, threonine, lysine and histidine. Right? Now, non-essential amino acid, it has been synthesized in our body, not in the diet. Alanine, glycine, serine, aspartate and glutamate. All these amino acids has been synthesized in our body itself. Yeah. So we have, so this will be the basic amino acids. 20 amino acids has been categorized based on the nutritional requirement. But based on the side chain, based on the property of a side chain, we are categorizing an amino acid into different types. So first thing, based on the side chain polarity, we can categorize the amino acids into non-polar. Non-polar in the sense they were water hating. It is not hydrophilic, but instead it is hydrophobic. So this is the first type based on the side chain polarity, and the second type will be polar but uncharged, and the third type will be positively charged amino acid and negatively charged amino acids. That is what charged amino acids. And yes, we are going to discuss about that. See, non-polar amino acids, those amino acids are water hating, that is it is a lipid loving, we can say like that. So glycine, alanine, valine, leucine, isoleucine, methionine, phenylalanine, tryptophan, proline. So all these were coming under the category non-polar and hydrophobic amino acids. Very, very important. No shortcut in that. You have to memorize all those things. Now, polar and uncharged amino acids, what will be the list? Serine, threonine, asparagine, glutamine, tyrosine and cysteine. So these are all the polar and uncharged amino acids, and if time permits for you, go through all the structures. By seeing the structure, you can easily easily categorize those amino acids and all these types. So positively charged amino acids, those amino acids which are positively charged, we are calling that particular amino acid as basic amino acid. Very, very important. Right? So lysine, arginine, histidine, all these amino acids are positively charged. So as I have explained you in the whenever we are dealing with the general formula for amino acids, so this is what an NH2, it is accepting a hydrogen. So those which are accepting a proton, we are calling that particular amino acid as basic amino acid. So by accepting a proton, that acquires a positive charge. That's all. Positive charge, basic, lysine, arginine and histidine. So these are all the positively charged amino acids, and also we are having negatively negatively charged amino acids, and that too acidic amino acids. So aspartate, glutamate. So these are all the negatively charged acidic amino acids. So very important. So aspartate, it is also called as an aspartic acid, and glutamate it is also called as glutamic acid. So this is all very important, and based on the chemical nature of the R group. So we are having an amino acids, and we are categorizing the type of amino acids based on different phenomena. Based on the nutritional type, we are having two different types, and based on the polarity of the side chain, we are having a non-polar, polar, and all those. And based on the chemical nature of an R group, further we are having different types. And what are all those types? Aliphatic R group, aromatic R group. Aromatic in the sense they are having a ring, that is the benzene ring in their structure. So sulfur containing amino acid, hydroxyl containing, sulfur is hydroxyl OH, and basic amino acid, acidic amino acid, amide amino acid, amino amino acid, because of the presence of amino group. And also see, amide amino group, already in their basic structure of amino acids, they already having an amino group in their structure. In addition to one amino group, they are also having certain other amino groups predominantly in that particular structure. That's why we are calling this particular amino group as a amide amino group. And also just look at this: aspartic acid and glutamic acid, lysine, arginine, and histidine. This has been discussed already in the previous slide. In serine and threonine, these are all the two amino acids we are having a hydroxyl group in their structure. That's why we are categorize them into hydroxyl containing amino acids. And also cysteine and methionine, very important. Sulfur containing amino acids were two amino acids. One is cysteine and another one is methionine. And also we are having aromatic amino acid. We are having three aromatic amino acids, that is phenylalanine, tyrosine, and tryptophan. Altogether we are calling them as an aromatic. Those structure which are having a benzene ring, that ring like structure is the aromatic amino acid. And the basic carbon hydrocarbon chain, that is what an aliphatic chain. So that is what glycine, alanine, valine, leucine. These are all the simplest form of amino acids. And the amino group will be present in the proline, and that's why it will be categorized in the amino acid containing group. See, one of the most important thing, kindly make a note of this. This glycine and proline is very important. Why? To maintain the flexibility of an amino acid, glycine is important. To maintain the rigidity of an amino acid, proline is important. Okay, this is important. Now, what are all these special amino acids? Glycine, it is very simplest and non-chiral amino acids. Glycine, and it is simplest. It is a simplest and non-chiral, and I have explained you why we are calling this particular as a non-chiral. And proline, that is amino acid. Amino acid causes bends in proteins. That is, this ensures rigidity. Now, cysteine. Cysteine forms disulfide bond like this. And methionine, this is the start codon. This is the start codon. AUG codes for the methionine amino acid. And histidine, this is involving in the buffering role. Very important. Now, coming back to the same thing, the Zwitterion concept, just now I have explained you. So as it has been accepting the hydrogen which is donated by the carboxylic group, it acquires a positive charge. As it is donating, it acquires a negative charge, and that is what is Zwitterion. So this is very important, and just look at this picture. And also you should know the many thing has the pKa values. But all the amino acids, they are having a pKa values. This pKa is nothing but a dissociation constant. We are going to discuss about all those things after finishing this. See, at a physiological pH, amino group, at a physiological pH, amino group will be like this only. At a physiological pH, which means in our body, the amino group will be like this, NH3+, and the carboxylic group will be COO-. at a physiological pH. This is how the amino acids will be. It will not be like the what we have discussed in the general structure, that is NH2, C, hydrogen, below we can have R, and the right side we are having a C over H. It will be not like that. So at the physiological pH in our body, it will be existing like this only, like NH3 plus and COO minus. As it have both positive and negative charge, we are saying that this amino acid exists as a dipolar ion. So they are having a ion here and again here ion, wherever there will be, say for an example NaCl. If it has been divided into gives Na plus and Cl minus, we are considered that as an ion. So as they are having one positive ion, one negative ion, this is why we are saying this amino acid exists as a dipolar ion, and that is why we are calling, technically we are calling this particular ion as a Zwitterion. Right? Just look at this picture. Now isoelectric point, and this isoelectric point that have been, 1 minute. Yes, isoelectric point. Now this isoelectric point, that pH at which amino acid has no net charge. See, whenever, so as I have mentioned you before, that NH3 plus, that is plus 1, COO minus and minus 1. So plus 1 minus 1 is equal to 0. That is what no net charge. So the pH pH of the at which amino acid has no net charge, at which pH the amino acid has no charge, that field, that point is called as an isoelectric point, does not move in an electric field. See, this is very important thing to understand. See, this is 1 and this is 7 and this is 12. At the physiological pH, that is 7, it acquires no net charge, and at that particular pH, I am saying for an example, it may be 2, it may be 3, and whatever it is, at the physiological pH, for each amino acid that will vary. So at any pH point, if an amino acid acquires no net charge, that is positive and negative, at that particular point, there will be no movement of that particular amino acid, and that point is called as an isoelectric point, and that has been represented as Pi. Now, what are all the importance of this isoelectric point? Protein purification. To purify a protein, this point to exist in this particular point is very important, and for the electrophoresis. And if we know this isoelectric point of that particular amino acid, and we come to know that at this particular point this amino acid can't move as it have no net charge. Electrophoresis, basically electrophoresis is a method where there will be the movement of a molecule towards a charge. Based on if the DNA is a negative charge, and the DNA, when we run a gel electrophoresis, the DNA will move towards a positive charge as it is having a negative charge. So that will be the process of electrophoresis, and we should know that, we know that, and this isoelectric point have no net charge as there will be no movement. And if we know the isoelectric point of a particular amino acid, we can know that at this amino acid will not move in this particular isoelectric this particular pH. Yes. And also to prepare a buffer, this Pi is very important. So all these things you will came to know clearly whenever you are doing a practicals, right? Just know that these are all the basic things. Now, what are all the acid base properties? First, you should know if acid is donating, which means if H plus has been donated by something, whether it will be an acid or a base. So acid, how acid will behave and how base will behave, you should know that. See, amino acids are amphoteric. So how do we discover, how do we name the plasma membrane? Plasma membrane, they are having a lipid bilayer, and that is a phospholipid, and phospholipid we are having a head which is hydrophilic, and the tail we are having a hydrophobic. As both hydrophobic and hydrophilic present in each same molecule, we are saying that as a what? Amphipathic molecule. So like in the same way, as both are having in the amino acid, in the same amino acid, one is donating a proton and one is acquiring a accepting a proton. So that is why we are saying this amino acid are amphoteric. So see here, can act as an acid. So which structure we are calling that as an acid? Acid which always donate H plus. So we are saying this carboxylic acid. So in the carboxylic acid, hydrogen is donated and this has been accepted by this NH2. As it is accepting, we are saying this particular thing as a base. So this amino acids are amphoteric. That is why we are saying, so as one amino acid is acting as an acid as well as a base, so that is why we are saying this amino acid as an amphoteric. This is very important point to know. So the same thing, that is what a peptide bond formation. So the peptide bond has been formed, a carboxylic group of one amino acid and the amino group of another amino acid has been linked together. And how? By linking, whenever it is going to link with one amino acid to another amino acid, it has been releasing a water molecule, and that is why we are saying this particular reaction as a condensation reaction. And what will be the name of the bond which is formed in the means of this reaction? And the name of the bond will be the peptide bond. How can we denote the peptide bond? So this is how it will be. This is what a peptide bond formation, and this is a condensation reaction. Yeah, now let's come to this point. Titration value of 20 amino acids is very important to know that. So we are having different types of an amino acid based on the polarity of a side chain. We have studied about the positively charged side chain, negatively charged side chain, and polar uncharged side chains, and special kinds of amino acids, and we are having hydrophobic amino acids. Just look at the titration value of each and every amino acids, and we are having positively charged side chains. And what are all the positively charged amino acids? Arginine, lysine and histidine. And they are having a pH of around after 7. It will be after 7. Just look at here. This is how it will be. And look at this picture. The negatively charged side chains, it has been, it will be like, the titration value will be like this. This is what negatively charged side chains, and the polar uncharged side chains will be aspartate, arginine, glutamine, serine and threonine. This is how the titration will be. And the special case of amino acids, proline, glycine and cysteine. And here all the hydrophobic amino acids have a lower pH value. So these are all the things are very, very important. See, the alanine. So in the alanine, so what we have, see, they are having a pKa value of 1 pKa value and pKa 2, and they are having an isoelectric point. What is meant by isoelectric point? Just now we have studied, at this particular point there will be no movement of an amino acid, so that is why it will be straight at this point. It will be straight. At which point, at which pH this alanine is isoelectric, and that will be 6.01, and this is very important. And what will be the pKa value? And that will be 2.34, and the pKa value 2 will be the 9.68. So all these things, which is nothing but donation of hydrogen and accepting of hydrogen. At which pH they are donating a hydrogen, at which pH they are accepting a hydrogen. See here, so just look at this picture. So in this pH, at this pH which is less than 2, at this pH they are accepting a proton, and they are not donating a proton in this pH. So this is called as a protonation, and this process is called as a protonation. Just look at this pH. At this pH they are, that is greater than 10, they are donating a hydrogen, but they are not accepting any hydrogen. As they are donating, as they are having a negative charge, this process is called as a deprotonation. And where they are having accepting of hydrogen and donating of hydrogen, and that particular point is called as the isoelectric point, and this is what a pH 6. So the isoelectric isoelectric point of this alanine will be the 6. So this is how all the values have been mentioned here. Kindly make a note of this. The same thing. So here I see here I have mentioned the same thing, same alanine. And we are having a different types of peptide. So as it is having if it is having one peptide chain, we are saying that as a monopeptide. And we are having dipeptide, we are having 2 number of amino acids. If we are having 3 tripeptide, we are having 3 number of amino acids. And so dipeptide means they are having 2 number of amino acids. Tripeptide in the sense 3 number of amino acids. Oligopeptide in the sense few, which means 2 to 10 amino acids, we are calling them as the oligopeptide. And polypeptide, many number of amino acids will be present there. And when we are calling this particular protein, so in this slide you should know what is the difference between peptide, amino acid, protein. Basic thing will be the amino acid. If 2 amino acids, we can call them as a dipeptide. If 3 amino acid, tripeptide. If 2 to 10, we can call them as an oligopeptide. And if we are having numerous amino acid, we are calling them as a polypeptide. And see here, many polypeptide chains, we are calling them as a protein. So if we call a protein, if we call insulin as a protein, that has to be many polypeptide chains. So this is very important. One or more polypeptide chains, and we know what is polypeptide, and in one polypeptide we are having many amino acids. That is what we are calling a polypeptide. And group of polypeptide, we are calling them as a protein, isn't it? Now, so there are different levels of protein structure. So coming to this point, you should know what will be the structure of protein. So we know that amino acid will make up a protein, and we have to make sure what will be the structure of protein will be. So there will be a primary structure, secondary structure, tertiary and quaternary structure. Just look at the difference of each and every structure. So in a primary amino acid structure, it will be linear. There will be no branch. Just look at here, it will be like this only. It is linear in structure. Just look at this secondary structure, it will be like this. It is a helical in structure. That is what alpha helix is. So if it is in an alpha helical structure, we are saying that as a secondary structure. In the tertiary structure, they are having a multiple alpha helix, beta pleated, and it also supported with many bonds, and that is what the tertiary structure. And group of tertiary structures together, we are calling them as a quaternary structure, and many loops will be present in the quaternary structure. So this is what a structural variation of each levels of protein. See, the protein secondary structure, this is how it will be. So this is an alpha helix. If it will be like this, like a helical structure, we are calling them as an alpha helix. If it is like this, it is a beta sheets, that is beta pleated sheets. This is how the protein structure will be. So again the same thing, protein primary structure, there will be a sequence of a chain of amino acids. Many sequence of chain of amino acids, we are calling them as a primary protein structure. And in the secondary protein structure, they are having a hydrogen bond. So the bond which is present in each and every structure is very, very important. This can be expected in a question. So in the secondary protein structure, which bond stabilizing a secondary structure means, that is what the hydrogen bonding. So the hydrogen bonding will be the backbone of each thing. And what will be the structure which is present in the secondary structure is alpha helix and beta pleated sheets. So this is important. Now comes to this tertiary structure. This 3D structure of a protein will be the tertiary structure. 3-dimensional folding pattern, that will be due to the interaction of the side chain. So we know that many amino acid, we are calling them as a polypeptide, and in the secondary structure again there will be the polypeptide, there will be many amino acid. If all the side chains have been interacted, so this looks up the 3-dimensional structure. So that is what we are saying that as a tertiary structure. So in the quaternary structure, the protein consisting of more than one amino acid chain. If the protein contains more than one amino acid chain, we are calling them as a quaternary protein structure. See, So the same thing but with different pictures, so that it will be little bit clear. Kindly have a look at that. So the same thing, primary structure, there will be the sequence of amino acids. So in the secondary structure, alpha helix, beta pleated sheet, and it will be stabilized by hydrogen bonds. This can be expected in the question. And see, there will be the 3D dimensional view of a polypeptide that will be exhibited only in the tertiary structure. And what are all the bonds? So hydrogen bond will be stabilizing the secondary structure. Now what are all the bonds which are involving in stabilizing the tertiary protein is disulfide bonds, ionic bonds, hydrogen bonds, and hydrophobic interactions. All of these bonds are involving in stabilizing the tertiary structure. And the quaternary structure is association of multiple polypeptide chains. Many polypeptide chains associating, altogether we are saying a quaternary structure, and example for this quaternary structure will be the hemoglobin, again a protein. Now, what will be the chemical reactions of this amino acid? So, chemical reaction of amino acids, we are having different types of chemical reaction. One is deamination and transamination, decarboxylation. D means removal of amino group. That is what deamination. So, transamination means transfer of amino group. We are saying transamination. Decarboxylation, removal of carbon dioxide from an amino acid. So we are saying that as a decarboxylation. This is what a meaning of each and every type of chemical reaction. Now by the means of this deamination, what is the goal of this amino acid to acquire? It has to produce an ammonia and keto acid. If there is any production of ammonia and keto acid is present in any of the body, then what is the main reaction taking place there? That will be deamination. Now, in transamination, if there will be new amino acid has been formed, if in any parts of our body, if there will be any transfer of an amino acid, if it forms a new amino acid, it is called as a transamination. And decarboxylation, if there is a removal of carbon dioxide, that is decarboxylation. And if in anywhere in our body, if it producing an amines, and which type of chemical reaction has been taking place, that is the decarboxylation. So this is also a very important thing. And what are all the biological functions of this protein? Amino acids, protein synthesis, enzyme formation, hormone production, neurotransmitter synthesis, energy source in starvation. So not only the glucose, that is carbohydrates, lipids, fats, that is lipids, but amino acid is also a provider of energy. So this is also very important. Now, see, amino acid, what are all the amino acids are very important for producing certain important product. It may be anything, even a hormone. So tyrosine is very important amino acid to produce a dopamine and adrenaline. And tryptophan is also a very important amino acid to produce a serotonin and melatonin, which is a hormone again. Glycine is very important to produce a heme and purines. Very, very important. Arginine, it is the product of arginine is very important for to produce a nitric acid and nitric oxide. Histidine is very important to produce a histamine, which is very important in the master cells. So all these are the amino acid precursors to produce different important compounds. So the first question, which of the following amino acid is optically inactive? So we know that we keep on saying the same thing. Glycine is optically inactive as it have no chiral carbon within it. So the isoelectric point of an amino acid is the pH at which it has no net charge, 1 plus and 1 minus. And which of the following amino acid contains a secondary amino group? Secondary amino group, that for this, to answer this question, you should know the types of amino acid based on the side chain. So which amino acid has a secondary amino group? That will be none other than proline. And which amino acid is most likely to form a disulfide bond? That will be the cysteine. Cysteine have a sulfidyl group that forms a disulfide bonds. So the question is different here. If it is a sulfur containing amino acid, you can come in to know that will be the cysteine and methionine. But here, which amino acid is involving in forming the bonds? Then that will be cysteine. Essential amino acids. So the essential amino acids here will be the lysine. So lysine is very important, that cannot be synthesized in our body. Peptide bond has been formed. Peptide bond is an amide bond, no doubt in that. So which amino acid is aromatic amino acid? That will be none other than the phenylalanine. So they are having a benzene ring within it. So at very low pH, the amino acid predominantly will be in so at a very low pH in the sense what? Which be less than 2, less than 3, just like alanine what we have discussed before. So they are accepting a proton. They are accepting a proton. So obviously accepting a proton will be NH3+, but they are not gaining a proton. They are not donating a proton. So this is very, very important. So that's why I have explained you the titration curve of the alanine. Just go through it. And which amino acid acts as a precursor of serotonin, and very, very important, you have to study that flow chart, that precursor chart, that will be tryptophan. And which amino acid is classified as an amino acid, and the amino group is present in the proline, so it is always the amino med group. So that's all about the class of today. So in tomorrow's class we'll meet you. Thank you everyone.